So for our first session, 45% of emissions come from construction, both in the creation of buildings, but also in the demolition and waste. There is now a great emphasis on retrofit, but also reusing what has been torn down. Kåre Stokholm Poulsgaard is from the Danish architecture and innovation firm GXN and is going to share with us how to demolish with care. Over to you.
Thank you, Alicia, and delighted that I could take part in this. Sounds like there's a lot of very good sessions here. So as said, my name is Kåre Poulsgaard. I'm a partner in GXN. We're a research innovation company connected to 3XN Architects. And I said we're based here in Copenhagen, but we got offices in London, in New York, in Stockholm, Sydney, and Amsterdam as well. And our office really works quite broadly across scales, everything from small externally funded research projects all the way up to master plan scale, and everything in between we basically do. A lot of offices do that, but I think what sets us apart is this structure here where we got an architecture company and an innovation company. We are two companies, separate companies, sharing one studio. And the reason for this is that there's a lot of research and innovation that can happen within architecture projects, but at the scale of architecture, if something goes wrong, the risks and the costs and the potential downfalls from it scale quite quickly. So 3XN do what architects do best, which is win competitions, develop great architecture with a Scandinavian twist, and then deliver projects on time and on budget. Thank you very much, right? And in that process, you do get to do a lot of research, but there's a lot of things you don't get to do. You don't get to test out a new material on your facade, or you don't get to play around with new technologies, because if it goes wrong, it goes very wrong indeed. And so that's what we do in GXN. We basically do all the stuff that the architects don't get to do. So this is us. We are the geeks to the architects. We get to get excited about new technologies, new materials, and run fast, test something, see what happens. Or we get sort of full into basement mode and follow the same problem and the same challenge over a long time and build up in-depth knowledge and figure out how to work with it. And increasingly, we're also being invited out of the basement and into the nice company with 3XN working on projects, which is great. We've built up a methodology in GXN, a way to work with open-ended problems and a lot of partners that we can now apply at scale in projects. So we figure out what works, and we seek to work now with 3XN and other partners to implement that into the built environment throughout all the stages, all the way from competition through to the final construction of the building. And nowhere is this more needed and apparent right now than around transformation. So this is what I'm going to be talking about today, how our combined studios approach transformation of buildings. I'm going to share 3 challenges or drivers that we are specifically working with, and then show you a bit of a case study for what it looks like when we're trying to do this at scale. To take a few steps back though and just get us started, for us, this whole focus on transformation, how to demolish with care, what we do with the existing buildings, started really with this book. This is called Building a Circular Future. It's still available online for free if anybody's interested. Latest update is a couple of years old now, but the first version of this book came out in 2013, and this is really where we started thinking seriously about what it would mean to introduce circular economy into the built environment. And one of the key sort of interesting findings from this is just how much care we take when we put up new buildings, how much skill, how many people, how much attention is paid, and then conversely, how little is paid when we take them down again. We don't treat our buildings very well once they get a certain age. Either they're torn down, well, they are torn down basically, and they're torn down in a way where it's very hard to reuse the resources. And this, of course, is a challenge. I think Alicia was giving you a few of the numbers. These numbers are from Denmark. So the built environment in Denmark consumes 35% of all society's materials. We generate about 37% of all waste, and we are responsible for 40% of CO2 emissions. If you don't want to remember these numbers, you just remember that the built environment is the 40% industry. So the bad news is that with numbers like these, we are very much part of the problem. The good news is that with numbers like these, we also have to be part of the solution. And this is really what we are working towards thinking about. It's quite an exciting, of course, daunting challenge, but quite an exciting challenge to be part of as well. So I mentioned I was going to talk about some of the drivers behind our work on transformation. The first one being this notion of carbon-driven design. The built environment is starting to take carbon into account in a much more coherent and serious fashion, and has been doing for the last couple of years, especially actually in the UK. So we all know we need to decarbonize the built environment, and we know we can get quite far with optimizing design, thinking about form, thinking about specification and materials. And so we're doing that work. And just as an example, this is not from the UK, this is from Toronto in Canada. This is a T3 building. It's built for 3XN, by 3XN for Heinz. It's their T3 concept, which stands for Timber, Technology and Transit. So it's a timber building. The key design concept here is that sort of stepped atrium that goes through the building as something that both ties the building into the public realm down in the corners, but also then creates this sort of shared space that can tie different companies together, create shared amenities, or if a large tenant takes over, make sure that you connect floors in new ways, create these sort of wow type spaces where people would really want to go. I said the building is a timber building, which is a bit of a challenge. So the Toronto building board only allows 6-story timber buildings. This is an 11-story building. So what we had to do to make sure that worked was put in a concrete basement, concrete first floor, and then a concrete core, which is where you have your lifts and risers and stuff, and then build a timber building around that, which is what we've done here. There's also a lot of work around sprinklers, which if anybody's interested, we can talk about. But other than that, the construction has actually proceeded quite quickly. So this is the 6.5 by 6.5 grids, modular mass timber construction. It was built, the timber side, once the foundation and the core was built, it was built around 6 months, which included a sort of trucker strike in the US. So it's quite a fast and efficient building process. And I'm being told it looks and smells nice on the side. I think there's a lot of excitement about this sort of raw timber, what that means once you come onto a building site. But looking at it from a carbon perspective, the key story is, of course, that utilizing timber rather than concrete, we can bring down what's called the embodied carbon of the building. That is the carbon that is contained in the materials we're using. If you want to make concrete, you need to make cement. If you want to make cement, you need to basically heat a lot of materials up to very high temperatures, and for that you emit a lot of CO2. Of course, you emit CO2 when you're making timber from plantation wood, mass timber products, but you're emitting a lot less. And so we're able to really save and bring down savings here using timber. This is getting us quite far ahead on bringing down the embodied carbon, but question is if it's going to be enough with the need to decarbonize, and we probably need to be able to go further. So this is one of the drivers, is need to figure out, well, how do we go further on bringing down embodied and operational carbon on our buildings? Offsets is one of my little pet peeves at the moment. So there's a lot of focus right now on net zero buildings. Net zero buildings means that you bring down the carbon, the operational carbon, which is the energy required to operate the building. That's coming from the grid. So we're expecting that to decarbonize, which means that the embodied carbon, the carbon in the material, is going to be more important. But basically, you bring your carbon in your building down as far as possible. You offset the rest, and then you have a net zero building. There's a couple of challenges with that. One being that the offsets really don't look like they're working. So this is recent research from The Guardian, a couple of other organizations looking into the voluntary carbon market, which is a $3 billion US dollar market for carbon offsets. They look into the 50 largest projects, that's the 50 projects with most investments into them, which investments, by the way, for $1.16 billion. And basically concluded that about 80% of these projects are likely junk, meaning that they don't actually have the impacts that they say that you've been sold as an offset. Another 16% are potentially junk, which means that they're just a tiny bit better, but they're still don't seem to be working. And the final sort of 5 to 6%, they couldn't conclude anything on because there wasn't any data. It's not great. It's probably not going to be a good option. It's also a risk investing a lot of money into something that turns out to be a problem down the line. So, well, here you have an artist's impression of your investors in the built environment once they realize that they've been offsetting their building against junk offsets, and now they need to find another way of dealing with that, redirecting money while being at the front page of The Guardian or some other paper, right? So really a challenge around offsets. The EU has quietly been working on the sides around this, and they're introducing a new piece of a new agreement, which then has to get international legislation. it's all about greenwashing, but the key thing here is that basically they're suggesting that you cannot, if this goes through, claim any net zero impact on the environment relying on offsets. So if this goes through, which we'll know in November, this might kill off net zero as a concept in the EU. What's happening in the UK, of course, is a little bit interesting. But that means that if net zero is off, out of the question, we need to start thinking about what are we then reporting, and we're probably reporting the carbon number. And so again, we'll have this market drive towards driving down carbon even further, as we can't hide behind this sort of net zero fig leaf anymore. Another interesting thing that leads us to focus on transformation is what we call the flight to quality. So what this really covers is the fact that post-COVID, but actually already before, but really post-COVID, we've seen a trend where a lot of, especially office buildings, are empty. People don't want to come back to work. They certainly want to come back to their workplace if it's not a sort of exciting building. A lot of buildings are underperforming as financial assets. What we do see, though, is that the best buildings, the highest quality assets, are still very much performing very well, are still sort of where people want to go. So there's a little bit of a bottleneck actually to get that, and they're performing better than expected. That's what you see on the graph to the left. On the graph to the right, there's a little bit of a research into what is it that means that an asset is high quality. And that means that you want larger floor plates, for example, flexible floor plates. You want to be able to have different office layouts, new spaces for meetings, collaboration spaces, shared spaces. There's some focus on indoor air quality and sustainability. What's interesting around this is basically that the shift in the market towards more sustainable and better performing buildings means that a lot of buildings that were considered all right just a couple of years ago are all of a sudden falling by the wayside. Talking to different developer clients that build and own buildings, we can see that this notion of a building being obsolete, meaning it not meeting market demands, is really sort of accelerating right now with this flight to quality. So we can see buildings that have been on the market for just 2 decades already being hard to let out. And this is, of course, a challenge because it means there's a lot of building stock that are going to be unloved, that are going to be hard to actually put out on, rent out on to meet market demands. But maybe from a material standpoint, still has a lot of life in it. So we have all these unloved buildings. These are some examples. We're working with all of these in our office. And all these unloved buildings need to be transformed so we don't have a large amount of waste coming from them. So this is some of the drivers that we're working with when we're working with transformation. Increasingly, the idea is that we can, by retaining a lot of materials and a lot of buildings, we can bring down carbon even further. Interestingly, there's a lot of education that needs to happen like this. It's rarely either or with the transformation. I'm sorry for the Danish in this slide, but basically, if you can imagine that out down here you have retention, up here you have demolition of the vertical axis, and then along the horizontal you have new builds. So basically you demolish some, you add something new, and these are all actual buildings from our portfolio that sort of fall in between. So this sort of idea of it, is it either or? Is it either transformation or retention, or is it a new build is actually a little bit more nuanced, which leads to challenges. As I'm sure some of you guys have heard, there's a lot of stories, building schemes getting a lot of bad press. One of the key ones is Marks and Spencer's on Oxford Street, where the team behind that specific project got a building permit to demolish the building and build a new one in 2021. There was a lot of fracas around that. It was elevated up to the Minister for Levelling Up and Housing, Michael Gove, who punted it further down along. So it was in 2022. And then this summer, 2023, they had their building permit revoked. And a bad time was had by everybody all the way through. There is a lot more nuances to this than this sort of either or debate. And what we're trying to do at the moment with the work we're doing is trying to educate ourselves, educate our clients, but actually also talk to the different municipalities where we work and try and make them see what is best for the different buildings. So we do that in a lot of different ways. We do these very detailed pre-demolition audits where we go in and map out all the materials in the building, volume, weight, how much carbon is captured in them. We develop what we call carbon budgets, ways of breaking down carbon targets for a building across the different building layers, which allows us to chase down carbon and understand where the hotspots are. We have developed a series of tools to model existing buildings trying to understand where the carbon is sitting in them and what retaining specific aspects of this might mean. And of course, we have series of tools for then developing carbon calculations of what we might add. So we can also calculate not just what we're retaining, but also what we're adding in. And of course, that's a real interesting thing. Is what sort of carbon are we displacing by retaining some if we're adding some more, and what might that look like? Increasingly, we're also then evaluating the buildings across all these other parameters, which is not just carbon, but we want to make sure that they're commercially viable, that they fit the market need, that they are flexible, that they live longer. Once we do these interventions, we will spend a lot of time and energy and carbon and money on doing an intervention. So we want to make sure that the asset is fit for purpose, that it's flexible, that it is healthy, that it has daylight, all these kind of things that make a building interesting from a market perspective. And of course, we're looking at the technicalities as well. And so it's a lot of different parameters and analysis going on, even now in the earliest stages when we're looking into building, trying to understand how we might transform them. All of this is part of that education process I talked about between us, our clients, our collaborators, and the municipalities where we're working. And the answers usually fall somewhere in between all these different things rather than being either or. Now, as a case study for what this might look like in reality, I want to show this one. This is a QQT, or the Kåre Tower, 3XN, finished for AMP Capital last year, 2022. It's this building here. It's in the harbour in Sydney. These 5 volumes stacked on top of each other, creating a high-rise where we try and create these sort of smaller, almost village type situations in the high-rise. Everything is twisted so you maximize the views out to the harbour without adding any extra shadow around the surrounding buildings. It's interesting in this sense because there was an existing building on the site, the AMP Tower here, which was finished in 1976. It was once the tallest building in Sydney, but it has since fallen behind, and AMP Capital, who owned it, had a hard time letting this out to the market. So remember I talked about the flight to quality. This was very much the problem here. This tower was considered not aspirational. The floor plate was considered too small. The offices didn't really look good. There was not really any amenities and so on. So AMP Capital did a competition saying, well, we would like architects to come in with a bid on how they might create a new building here while retaining as much as the existing tower. And so, of course, you look into the existing tower, try and understand, how old is it? How is it built? What sort of state is the concrete in? So a lot of tests with that. Interestingly, for this one, it's built with this perimeter column system. So you have the core in the middle and then these perimeter columns, which means there's a lot of flexibility to cut and carve on that floor in between, which becomes interesting in terms of figuring out how to potentially retain while also adding new buildings to this. It of course had great views over the harbour, so a lot of intrinsic value there that could potentially be unlocked. It had, let us say, an underutilized ground floor and didn't really do much in terms of public use. So there was an opportunity to do something there. And of course, as I said, the offices weren't exactly aspirational here, right? I mean, the windows weren't not really good views. These sort of lowered ceilings, not a particularly nice prospect necessarily compared to the site where you were in the middle of the CBD in Sydney. One thing it did have, though, was fairly good floor-to-ceiling heights or floor-to-floor heights, which is usually a challenge. Some of these had set a little bit over time as the building sort of stands, especially at a high-rise like this. It'll set under its own weight, but we could go in and work with the contractors and the engineers and figure out how much it had set and see that this was still good to work with. And I should say this is, of course, a collaborative effort. So we were working very closely with Arab as engineers here, and B&B, a Sydney-based architecture company, and then Multiplex were the contractors doing this. So to transform the building, the idea is basically to peel off or take off the front all the way into the core, graft on a new core to be assured to have the servicing for the new floor slabs you're putting in, and then double the floor slab sizes by adding these new platforms out. We managed to retain 2/3 of the existing tower doing this, retaining 95% of the existing core, where it has a lot of concrete tied up in it, of course. And so here you can see sort of what was taken away, what was being demolished. all the way into the core, as I was showing here, and then readying that core to be grafting on a new core to add additional lifting capacity, building out the platforms, doubling the floor plate, adding a new facade, and having basically a new building here. And voila, this is what it looks like. But working with that, of course, there's a lot of stuff that had to be dealt with. Here's some side photos. So one thing is stripping the building of its facade all the way around, of course, a bit of architectural striptease there. Reinforcing the foundations, making sure that everything would work during the construction process. Also then demolishing the floor slab that was sticking out all the way into the core. And this was sort of happening almost in tandem with some of the construction. So a lot of logistics on site to work out here. To make sure that all of this could work and work at the precision it was needed, Multiplex had developed this digital twin, which is a digital model of the building, which was then constantly enriched and informed by actual studies being carried out during construction. We can only really do in-depth studies of the concrete, sampling, testing, reinforcement, and so on during the actual demo and construction process. All of that would be fed into the digital twin, which would give the most accurate picture and allow the team sort of accuracy during construction when grafting on the new core and building the platforms around. And so a lot of reinforcement, of course, going into the existing building and core where the new elements were going to be grafted on. Interestingly, and here you can kind of see here that little tower, it says Multiplex, that's the existing, so that's a new core being cast in conjunction with the old core. That, of course, had to fit. That leads to a couple of challenges as concrete shrinks slightly when it sets. So to work with this, the team developed a connection detail utilizing rebar and the new core wall, but actually left a little bit of space in between the old core and the new core wall, which would allow the concrete to set and shrink, bend the rebars, and then basically pour concrete into that hole in the end once everything had set into place to avoid cracks and anything in the finished building. That same approach was used for the platforms, or similar approach, not the exact same, but a similar approach was used for the platforms, where there was actually left a 4-meter gap in between the new platform and the old building during the demo and construction, which was only grafted and closed at the end once everything had built up and everything had maybe set a little bit. So we were sure nothing was going to crack under the weight of what was being built on top during the process. And so here's a little bit of a time lapse where you can see the scaffolding going up to peel off the facade. You can already see the preparation in the ground there for the new site and the reinforcement. The facade is coming down now, and the demolition of the front slab up all the way into the core. Extension of the core there. In a second, you'll see the new core coming up. You can see that sort of slipcase moving up while the platforms are being built out, and a new facade being added, wrapped around the whole building. And that new facade, of course, encases the building. And so actually in the interiors, you don't really notice whether you're in the old or the new building. You just have a new building that hopefully stands out as sort of a completed and concrete whole. And there it is. And so what's interesting that in light of some of these drivers was that, of course, we were answering this sort of driver towards flight for quality. We're doubling the floor plate, creating a lot of new amenity spaces, new valuable offices. We were also able to save a lot of materials. 2/3 of the existing buildings were saved, and that means we were able to save a lot of carbon that we didn't have to expend on creating new concrete to build a whole new tower. So about 2,000 tons of carbon emissions were saved in this project. We were also able to save a lot of money for the clients. So this is about 68 million pounds by retaining the existing structure. And this is really not just in material cost, but it's also in time saved. So we estimate we saved about 6 months in time, both in demolition and construction, because we didn't have to demolish the thing fully and then build up new. And time on a building site in the central business district is worth a lot of money, right? Doubling the floor plate, as I mentioned, increasing and doubling the capacity of this building. Creating these new high value spaces with these atriums that can bring light into the building, connect floors, give people a little bit of a view of each other. There's an interesting thing here in terms of thinking about the future viability of this building. We were having discussions with the client around whether it would be feasible to have these atriums. They weren't sure that there was going to be a market for it. And so one of the things we did was create the building with the atriums, but building them with these platforms that you could put in to close out the atriums. And these are designed with sort of key circular economy principles. So simple, easily available materials. Everything is designed for disassembly with mechanical fittings. Everything is dimensioned so it can go into the freight elevator and actually be brought out without having to put in cranes and stuff. And so what that creates is creating flexibility to actually test this out. And as the tower was being built and rented out, all the different tenants would come in and they could decide whether they wanted to close floors up, which nobody did. But I think there's another sort of point to what we're doing when we're doing transformation is making sure that we build in future adaptability so that this tower can have a longer life and be adapted to future uses in 10 years, 20 years, 30 years even. Tower itself creates these new nice terraces, great views out over the city, of course. Here you can see the interiors, both in terms of the office spaces and a little bit about the public realm. There's a large public realm podium developed for this project as well. A little bit of facade. And finally, here's the tower. And with that, thank you very much. And I'm happy to take any questions. If you want to know more about any of this, feel free to contact me on the email up here on the screen.
Thank you, Kåre. I love the way that you have paired demolish with care, not just two words that you usually combine together. So we're just going to go through the Q&A. So if any of you have any questions, please put them through. First question is, a lot of the carbon measuring focuses on big data. You mentioned the use of digital twins in particular for one of your projects. How do you see this being deployed for smart cities, for instance?
So just to understand the question, whether the availability of city scale data can inform carbon calculations for projects?
Yeah.
I imagine it can. I mean, one of the interesting things is we're doing this now on a project by project level, basically trying to build a model of existing buildings and of course a new building, and using those models to calculate carbon impacts of different decisions and thereby inform decisions, right? What becomes interesting if you're looking at a portfolio level, for example, if you're a developer owning a large building portfolio, would be to get that portfolio overview of your decisions across the portfolio, trying to understand where to direct your money to get most impact. We're talking to some developers around this. I can imagine if you were a city, you're owning a lot of buildings, that sort of scales up even further. And so having data to inform that modeling would be crucial. I think there's some challenges around getting access to that data and making sure that it's precise enough to actually inform modeling that can enable decisions is I guess the challenge and the interesting opportunity. But definitely having, let's say, a portfolio or neighborhood level overview of where you would get most bang for your buck in terms of investing into different strategies would be a very interesting prospect.
You also mentioned that the EU, in terms of like greenwashing and kind of banning that aspect, has a really big, obviously, significance for how net zero is going to kind of like I guess deplete. If that does happen, what could designers look out for in the future, and where do we go to understand more about kind of different opportunities?
Yeah, so I mean, the net zero debate is big and hairy, and there are arguments for net zero if you can actually sequester carbon underground where you dug it up. Sequestering carbon in forests is a bit of a challenge because you have the time perspective. But rather than get into that, I think the interesting thing with a ban on net zero based on offsets is that if you take that away, you basically need to start talking about the actual numbers. Net zero just allows you to say my building is net zero. If you can't say net zero, you might need to be able to say, well, my building hit 450 kilograms of carbon per square meter over 60 years, or whatever it is. So I think that's going to drive a push towards transparency. And to me, the best way of dealing with that in terms of what are we looking into in the future would be to develop the tools to become transparent and develop the tools to inform decisions to try and drive down carbon, whether that is tools to make decisions at the very earliest stages around whether to keep a building or not. As architects, we are sometimes brought in, or we are most often brought in after the business case for a project has been set. And if that business case says demolish and build new, it can be very difficult for the building owners to change that way of thinking. So I think as designers, I think thinking about how to get involved in the business case stage, how to evaluate existing buildings during the acquisition process, how to make that portfolio level overview about investments, I think is a very interesting field where we could do a lot of interesting work. The other more practical side is how to become genuinely transparent, not just about our numbers, so we hit this carbon target, but actually also becoming transparent in sharing our models, being a little bit more open source, allowing people to, see how we got to the numbers. So yeah, in general, I think transparency and finding ways to inform decision making and cash flow is where we should be going.
Sounds good. So Sarah asked a question: Do you use a preferred existing surveyor to aid data modeling for the existing condition of the sites or buildings?
We work with a couple of different ones. We have been working with BRE to do these pre-demolition audits. We've been working with a company called Reusefully to do these. We're looking at a couple of other potential collaborators. I think there's a growing field of companies coming in who can manage that side of it in terms of going out and actually surveying the building and creating the pre-demolition audits. Of course, when it comes to understanding so the pre-demolition audit just is an inventory of the products and materials in the building. When it comes to understanding the transformation potential, we need to go quite a few steps further in terms of understanding, let's say, the bones of the building, the structural system, its state, and there's a lot of other partners coming in. So we're doing a lot of work with the large engineering houses, with contractors, specialist surveyors, people who can understand the concrete and so on.
Great. There's another question from Thomas Slav. Nice presentation and a groundbreaking building. I think we can all agree. How does one pursue a client to do such an undertaking? Were lower costs and shorter construction time aspects that sealed the deal for QQT? QT?
Yeah. It's a great question. I mean, it's a key question, right? How do we incentivize this? The story about QQT was that, as far as I'm aware, it was already enshrined in the competition that there was going to be a focus on retaining as much of the existing building as possible. I believe that drive was also helped a little bit with maybe I need to follow up on this, but basically the city saying to the building owner, MP Capital, that the more you retain, the more square meters you're allowed to add to the site. So a very tangible incentive there, saying, you can really increase the value if you retain. So some sort of outside push helps. We can see a lot of focus in London right now through the circular economy statement that this Greater London Authority has introduced to do a lot of these studies during planning. I think documenting the actual impacts of this and documenting that we can save time and money is also key. So external pushes helps, but some of the more sophisticated clients are starting to see that not only does this make sense sort of in a strategic way of positioning themselves in the market, but that they can also start seeing that there's opportunities here that can really help them be smarter around how they manage their portfolio. And so I think it's a little bit of a back and forth, and there's also kind of an interest from the market around these things.
Brilliant. Thank you so much, Kåre. So that will be the end of this session. Stick with the how-to stream for our next sessions on how to be inspired by biology in your design, or head over to the main stage for a panel discussion about the future of mobility. Thank you so much for joining.
Thank you.